Today we're going to go over compositions of functions. So another way to combine two functions is to form the composition of one with the other. For instance, when f of x is equal to x squared and g of x is equal to x plus 1, the composition of f with g is written like this. So this is f of g of x. So we would take what g of x is and plug it into what our x is in f of x. So we take what's on the inside and plug it into what's on the outside. So we can write the composition as f of g. So this little fog is, we read it as f of g, or we could write it as f of g of x. I always like to write it like this because I can see that we're taking the g of x and plugging it into the f of x equation. But these are the same thing, this fog and this f of g. So again, it's written here. These are the same thing. The domain of f of g of x is the set of all x in the domain of g such that g of x is in the domain of f. So in English, to find the domain of a composition function, if we had f of g of x, our domain of f of g of x would be the domain of g of x and the domain of the whole thing. So we just need to make sure that our domain is what's in the input and our whole thing, and what's in common between those, which we'll do some examples where we show that. So going to the right side of our page, example 5, we need to find f of g of x for f of x is equal to the square root of x when x is greater than or equal to 0, and g of x is equal to x minus 1 when x is greater than or equal to 1. If possible, find f of g of 2 and f of g of 0. So first thing we need to do is find f of g of x. So I'm going to rewrite this as f of g of x. So I take what our g of x is, and I'm going to plug it in to our x in the f of x equation. So I could also just take this g of x and plug it into our f here. So this would be f of x minus 1. This way I know x minus 1 is what I'm plugging into our f of x equation. So our f of x equation is the square root of x, so I just plug in x minus 1 for x. I cannot simplify this anymore, so this is our answer for f of g of x. And then I need to plug in 2. So I'm going to plug in 2 for x in our equation. So I have 2 minus 1, which is just the square root of 1, which is 1. And then we need to find f of g of 0. If we plug in 0 here, we have 0 minus 1. The square root of 0 minus 1 is the square root of negative 1. We can't do the square root of a negative number, so this is no solution or does not exist.
What does fog stand for?
So fog, so this is f of g of x, which is also written as f of g of x. So these are the same thing.
We don't use imaginary numbers for this?
Nope, we don't use imaginary numbers. We're only dealing with real numbers here. So if we get a negative under our square root, it doesn't exist.
Wait, Miss Carver, can you go back? Where'd you get the radical x minus 1? I got everything else except like the first part.
Okay, So our composition here is f of g of x. We need to find f of g of x. So we take our g of x and plug it into our x in our f of x equation. So we're substituting the x in here for this g of x equation, which is x minus 1.
Okay, I see. Thank you.
You're welcome. Okay, so let's look at any other questions from example 5. Let's look at example 6. So we're given f of x is equal to x plus 2 and g of x is equal to 4 minus x squared. We need to evaluate f of g of x and g of f of x. So when x is equal to 0 and 1. So first we're going to find f of g of x. I'm going to rewrite this as f of g of x. These two are the same thing. I just can visualize this better because I know I'm taking g of x and plugging it into our f of x equation. So I'm going to take our g of x and plug it into the x in our f of x. So when I plug this in for x, I get 4 minus x squared plus 2. Now I can simplify our equation. 4 plus 2 is 6, so 6 minus x squared. So our f of g of x is 6 minus x squared.
Do we plug in those numbers that they give us after?
Yep, now we're going to plug them in. So here we have f of g of 0. So this would be 6 minus 0 squared, which is just 6. And then we can plug in f of g of 1. And this is 6 minus 1 squared, which is 5. Now we need to find g of f of x. So we're taking our f of x and plugging it into the g of x equation. So we're taking this x plus 2 and plugging it into the x here. So here we have 4 minus, we plug in this x plus 2 for x, so we would have x plus 2 squared. And now we can simplify this equation. Since we have a binomial that's squared, we would need to FOIL. So this is x plus 2 times x plus 2. We multiply our first terms together, get x squared, then our outsides, then our insides, and then our last terms. And then we simplify. Oh, but I almost forgot. All of this is in parentheses, and this negative distributes to everything inside. So we have this negative times x squared, negative times 2x, negative times 2x, and negative times the 4. So we just need to distribute that negative to everything inside our parentheses. So this becomes 4 minus x squared. I'm going to combine our two x's together. So 2x plus 2x would be 4x. So this is a minus 4x and then a minus 4. What can we do next?
Subtract the 4s.
Right, 4 minus 4, they cancel each other out. So we have negative x squared minus 4x. So this is our g of f of x.
Why couldn't you just distribute the 2 to the x and the 2? Like, I mean the square, like the power of 2 there, instead of doing the binomial thing.
if we have two, like if we had any x plus 5, x plus whatever, 6, we have to FOIL. So when we're multiplying these two, we have to FOIL.
So you wouldn't just distribute that inside. You have to separate them and then
Right.
FOIL it?
When you're multiplying two binomials, you have to FOIL. If you were just like, let's say x times x plus 2, here we could just distribute.
Okay.
But when it's two of them, you have to FOIL. Okay, so next we need to find what g of f of 0 is. So we're just going to plug in 0. So this is negative 0 squared minus 4 times 0, which gives us what?
0.
0. And then we plug in 1 to find what g of f of 1 is. So this is negative 1 squared minus 4 times 1. What do we get here?
Negative 5.
Awesome, negative 5. So this is negative 1 minus 4, which is negative 5. All right, let's take a look at example 7. So here it's asking us to find the domain of f of g of x for the function for f of x is equal to x squared minus 9, and g of x is equal to the square root of 9 minus x squared. So when finding the domain of f of g of x, we need to find the domain of our input here, so what's inside our parentheses, and then find the domain of the whole thing, and then our domain for the whole thing is what's in common between these two. So first, let's find our domain for g of x. We have a square root here, so we know that we can't have any negatives inside our square root. So what should we do to find out what our domain is here? What do we need to do first?
You need to plug in the g of x to the f of x.
First thing we need to do is find the domain of g of x. So how can we find the domain of g of x?
That's where I'm getting stuck on to, like, domain.
Well, we know we have a square root, so we can't get a negative under the square root. So we're going to set this equal to 0 to find out what our key numbers are. So we have 9 minus x squared is equal to 0. Now to solve, we add x squared to both sides, and we get 9 is equal to x squared. Take the square root. What's the square root of 9?
3.
Just 3?
Oh, plus or minus 3.
Plus or minus 3.
Yeah.
So positive 3 and negative 3 are our key numbers here. So I'm going to put them on a number line. Now to find out where our domain is here, it's either going to be inside our key numbers or outside our key numbers, so we need to test both. So first thing, we can plug in a number outside, so let's plug in negative 4. If we plug in negative 4 here, this would be the square root of 9 minus negative 4 squared, which would be 9 minus 16, and we would get the square root of negative 7. We can't have the square root of a negative, so this does not work. So outside of our negative 3 does not work. Next, we need to check a number inside. So what's a number inside that we can plug in between negative 3 and 3?
2.
Why don't we pick 0, since that's going to be
Yeah, 0, yeah.
the easiest. So let's plug in 0. So we have 9 minus 0 squared, which is just the square root of 9. This is positive, so this works. And then if we plugged in 4, we would get a negative number 2, so outside doesn't work. So our domain for our g of x function is going to be from negative 3 to positive 3. Do you think it's including or not including?
Including.
Including. And to test that, we could always take -3 and plug it in and see that we get 0. And we can do that. We can take the square root of 0. We could do the same with 3 too. If we plug in 3, we get 0. So that's how we know it's including, because you can take the square root of 0. So we have brackets, -3 to 3. So now that we found, yep.
How did you know that we couldn't have any negative in the square root for this one?
That's like that, like you just can't have negatives in the square root always. Like anytime you see the square root of a negative number, you learn in like algebra 2 that that's I. That's an imaginary number. We're not dealing with imaginary numbers now, we're only dealing with real numbers. So we can't have a negative under the square root. So our restrictions for our domain that we'll see often is that the square root, so a square root can't be negative, and we can't have 0 in the denominator. So these are 2 that show up pretty frequently. And this is what restricts our domain. So like for the first example for 6, we have x plus 2 and 4 minus x squared. Here we don't have any square roots, so we don't have to worry about that, and we don't have any fractions, so we don't have to worry about 0 in our denominator. So our domain is always all real numbers. So for this one, we don't even have to worry about the domain because it's all real numbers. But when we see a square root and when we have a fraction, that's when we have to think about our domain. So for 7, since we have a square root, that's where we have to worry about our domain. And we have to find out on what scale does our function work and when does it not work. So our function here only works in between -3 and 3. So that's why we have to say our domain. Because outside of -3 and 3, if we had 4, this becomes imaginary and then it's not a function. Does that answer your question? Make a little more sense?
Thank you.
Okay. So now that we found the domain for g of x, we found the inside, we need to find our domain for f of g of x. So that means we have to find what f of g of x is. So we're going to take g of x and plug it into our x in the f of x. So we have f of g of x, which is the square root of 9 minus x squared squared minus 9. So all I did was take our g of x and plug it into the f of x function. And now I can simplify. If I'm squaring a square root, these 2 cancel out. So I'm just left with 9 minus x squared and then minus 9 on the outside. Everybody with me so far?
Yeah.
So we can square root to get rid of the power, right?
Yeah, so we had a square root on the inside and we squared it because this was x squared. So they cancel each other out.
Okay.
So I'm just left with what's on the inside now. So what else can I do to simplify this?
9 minus 9.
9 minus 9.
Negative x squared.
So we just get negative x squared. Do we have any square roots here or any fractions?
Would be like the x squared, right?
Is this a square root?
Oh, no,
Well,
no.
we can't
No.
square root it because then we'll get an imaginary, right?
Right. We don't have, so here our domain, so for f of g of x, our domain is all real numbers. because we don't have to worry about any square roots here. We don't have to worry about any zeros in the denominators. If we were to graph this, our domain would be all real numbers. So if we put these together on a number line, and these together, I mean the two domains, so our domain of f of g of x, so this one, and our domain for just g of x, this would be, so our domain for f of g of x would be the whole number line, and then our domain for just g of x is only from -3 to 3. So our domain for our function is only what's in common between the two. So what's in common is just from -3 to 3. So our domain for the function here is from -3 to 3. So to find our domain for our composite function, we have to find what our domain of the input is and what our domain of the whole thing is, and take what's in common between those two. The domain of f of g, so we only have to do f of g of x. Okay, ready for example 8? I'm going to take the silence as a yes.
Yeah.
So here we have two functions, f of x and f of g of x. We need to find f of g of x. So for the first one, this is the same thing as f of g of x. So we need to take our g of x and plug it into our x in f of x. So we have 2 times 1/2 times x minus 3 plus 3. And now we simplify. So 2 times this 1/2 would just be 1. So we would get x minus 3 plus 3. The minus 3 and the plus 3 cancel out, so we're just left with x. So our f of g of x is just x. Any questions there?
Does that mean that's all real numbers?
Yep. So our domain would be all real numbers. To check our domain, we would just have to make sure that our domain of g of x is all real numbers and our domain of f of g of x is all real numbers, and then our domain's all real numbers. So this, for g of x, our domain would be all real numbers, and then if it's x, our domain is all real numbers, so then our domain of the whole thing would be all real numbers. So you always have to check what the domain of the input is first.
Is that what we found out just now?
Well, what we found out just now was just what f of g of x is.
Just f of g of x.
Yeah.
So how would you know the one of just g of x?
So just g of x, it would only ask us what the domain of f of g of x, and we would have to test what the domain of g of x first is, and see what's in common between the domain of g of x and f of g of x.
Okay.
But this question's not asking us for domain, it's only asking us for f of g of x and g of f of x. So now for g of f of x, we take g of x and we plug in our f of x. So we're going to plug in our f of x into our g of x. So I have 1/2 2x plus 3 minus 3. What do I do first to simplify this?
You subtract 3 from 3.
Right, so 3 minus 3 is 0, they cancel out. So we have 1/2 times 2x, and what do I get?
You get 1 of x or just x?
Yeah, just x. And that's all we have to do.